Solving a system of inequalities. In this lesson, you will learn how to graph a linear inequality and how to solve a system of inequalities. What do we already know? We've already learned how to graph a linear equation and how to solve a system of linear equations. So let's graph each inequality. We're going to have two inequalities. The first one is 8x minus 3y is less than or equal to 12. The second one is y plus x is greater than negative 3. We have two variables, so we're going to be using a coordinate plane. And just like equations, we're going to put our inequality into slope-intercept form to make it easier to graph. So let's focus on the first inequality. We're going to subtract 8x from both sides, and then we're going to divide by negative 3 to get the y by itself. Remember that when you divide by negative 3, your inequality switches from less than to greater than because you're dividing by a negative. Now we're going to use our y-intercept of negative 4 and our slope of 8/3 to graph our inequality. So we have our coordinate plane, and then we graph negative 4 on the y-axis, and then using our slope of 8/3, we graph our line. Our line is solid because we have the equal to underneath the greater than symbol. Whenever you have an inequality, there are two things you need to pay attention to: whether the line is going to be solid or dashed, and where you're going to shade. Because an inequality encompasses all of the points that satisfy this inequality, that's why we need to shade. There are lots of points that are involved in this situation. So we have a solid line, and then because it says y is greater than, we're going to shade above the line where the y values are greater than the points on the line and on the other side of the line. So now let's look at the other inequality. We want to get y by itself, so we're going to subtract x from both sides. Now we have it in slope-intercept form. So we can use negative 3 as our y-intercept and negative 1 as our slope. Now this time our line is dashed because we don't have the equal to underneath of the greater than symbol. And then because it's greater than, again, we're going to shade above the line. So any point in the shaded region will satisfy this inequality. It will give us a true statement if we plug it into the inequality. Jake's ship can carry up to 15 people and 2,400 pounds. On average, a child weighs 80 pounds and an adult weighs 180 pounds. What combinations of children and adults can ride the ship at one time? So first we need some variables. Let's let C equal the number of children and A equal the number of adults. So our first inequality is going to be an easy one. We're just going to look at the number of the people. So C plus A is less than or equal to 15 because the ship can carry up to 15 pounds, but it doesn't have to have 15 pounds, it can carry up to 15 people, but it doesn't have to have 15 people on board. The second equation is going to involve the weight that the ship can carry. So if we take each child and multiply by 80, that gives us the total amount of weight for children. If we take each adult and multiply by 180, that gives us the total amount of pounds for the adults. And then that's got to be less than or equal to 2,400 pounds. So our two inequalities are C plus A is less than or equal to 15, and 80C plus 100A is less than or equal to 2,400. So let's solve this problem by graphing. We have our first inequality, which was C plus A is less than or equal to 15. And we can solve for C by subtracting A from both sides. So we have a y-intercept of 15 and a slope of negative 1. So let's go ahead and graph that. So on our coordinate plane, we have the vertical axis, which is C, which is the number of children, and then we have our horizontal axis, which is A, the number of adults. So we can graph our line using 15 as the y-intercept and -1, -1 as the slope. So there's the graph of our line, and again, it's equal to, so we have a solid line, and we're going to shade below that line. We cannot include any numbers that are above this line. So we're going to shade below, but we're going to hold off on the shading until we see what the other inequality is going to look like. So then we have the other inequality that represented the weights. 80C plus 180A is less than or equal to 2,400. So we start off by subtracting 180A because we want to solve for C. Then we divide everything by 80, and we get C is less than or equal to 30 minus 9/4 A. So again, we use 30 as the y-intercept and negative 9/4 for our slope. So we can graph the line for the weights. So now, again, it said less than, so we're going to shade below. Well, because this is a system of inequalities, we only want the areas where both inequalities would have the shading. So if we look up here, only below the yellow line would be shaded. And then over here, only below the pink line would be shaded. But in this general area is where both graphs would be shaded, so all of the points within that shaded region are the answer to the problem. So we could have various points, such as 0 adults and 10 children, 2 adults and 10 children, 4 adults and 10 children, 2 adults and 8 children, and so on and so forth. All of the points included in this shaded region would satisfy both of these equations.